I'm recording now. Okay. All right. Okay. So again, last time what we started doing was, let me see, recording. We started looking at polynomial multiplication. Okay. And again, we went through first how to multiply two monomials together, right? There was a process for that. That's on slides that I already posted. And not only, and basically there, it's actually not that bad how you multiply monomials. What's nice is you don't have to worry about like terms or unlike terms. You can multiply any two, monomials together. And once you know how to do that, you can then multiply polynomials together. And one method I did show you last time was distribution. And the other method I'm showing you is called the grid method, the box method, I think some people call it, or the table method. And these are the steps. I did go through an example last time. These are the steps that I took. Basically, we'll see more examples today, of course, and I'll let you try some as well. So what you basically do is you're given two polynomials, right? And you have to multiply them. You're going to form a grid with rows and columns. From one polynomial, you'll get the columns, namely each term in one polynomial, you'll get a column. For the other polynomial, each term will give you a row. So you'll see, as you probably saw in the example from last time, there are rows and columns. And to fill in the missing entries in the grids, you multiply row and column entry, the corresponding row and column entry. And then you add up all the grid entries together. That's actually how you get the product. And then, of course, it's good to write your answer in standard form. So really, both methods are based on multiplying monomials and, distributing. It's just this method with the grid method, I just think is a little more visual. Okay. And I also posted a video by Khan Academy. You don't have to watch it. It just shows more examples in case you want to see more. I know some people learn differently, so that's why I figured it'd be good to post a video. That site, virtualnerd.com, has examples as well, although they're not closed caption though. But, if you want to watch them, you're more than welcome to. Okay. All right. Okay, so let's get to some examples. So this is the example we want to do. What we want to do is multiply these two polynomials together. Okay? So again, what we're going to do is we're going to form a grid. Now, what I like to do is the polynomial with more terms. I like to use that for my columns. So each term here is going to give us a column, as you can see. And each term in the other polynomial gives us a row. Right? So you can see that each term here, we get a column. Here, each term from the other polynomial, we get a row. And now we have these missing grid entries here, right? And as I wrote in the previous slide, to fill in the missing entries here, you're going to multiply row and column entries together. So let me say that again. You multiply corresponding row and column entries together. So for instance, the first entry, you're going to multiply x cubed times x to the fourth. When you do that, you add the exponents. That's how we get this. Normally, you would multiply the coefficients together, although here they're both equal to 1, so not much is done there. Same thing over here. For this one, we're going to multiply first row, second column entry. Doing so, we get this. 6 times x raised to the 5th. 6 times x raised to the 5th. Okay. Over here, right, x cubed times 1, we just get x cubed. So we are multiplying here, as you can see. Okay. Here we have the second row term times the first column entry. So 2 times x to the 4. Well, that's just 2x to the 4. Nothing too fancy there. Here we have 2, for this one, we have 2 times 6x squared. We get 12x squared. And finally, 2 times 1 is just 2. Now, we're not quite done yet because we want to get the actual product, but that's easy from here because we just add up these entries together. Okay. And when you do that, as you can see, we're adding up the entries. Notice, so we're adding, sorry, let me say that again. We're adding up the entries here that we just filled in, right? Notice I wrote it in standard form, meaning the exponents are decreasing as you go from left to right. Now, let me also say this. Not in this example, but sometimes what could happen is on these diagonals, I think in the next example you will see this, but on these diagonals you could have like terms. You know, if you see them, you could save some time by adding them together. Not always, but sometimes though. Okay, so that's one example. Let's do another one. You know, it's just like anything. You're not going to get, no one can get good at this unless they practice, including me. So we have this example now, as you can see, like so. Okay, so what do? We're going to multiply. So again, what I like to do is I like to use the polynomial with more terms for the columns. Do you have to do that? No, you don't, but you can. So here I have 3 terms. We get 3 columns. The first polynomial, each term gives us a row. And that's what we get here. Again, you could use the first polynomial here for the columns. So in that case, you would have x to the 4 as a column, x minus x cubed as a column. You could do that. And then these would give you the rows. It really doesn't matter. You know, if you do everything correctly, you will get the right answer. And as I said before, you could use distribution directly to multiply 2 polynomials. This method I just think is a little more visual, which is why I like it. So whatever method you use is fine. Okay. I think in that video I posted, there's actually another method he uses. So, but again, if you want to use that, that's fine also. Okay, so back to this. So again, each term here is giving us a column. Each term in this polynomial is giving us a row, as you can see. Now we have to get these products. Notice that I'm including the minus sign. You want to make sure you do that. You always include the minus sign if it's there. Okay, so for this one, what do? We have x to the 4. Let me just check something. If anyone has any questions, then nope, we're good. So again, we have x to the 4 times x squared, right? And what is that going to give us? Well, that gives us x to the 6th, right? Row times the column term. Here, what do we have? We have x to the 4th times x. That gives us x to the 5th, which we have. Okay, so again, we're multiplying row and column terms. For this one, we're going to have x to the 4 times minus 5. That gives us this. I mean, there's not much really you're doing here. You just write the number, the constant, you're going to write in front, and that's the coefficient. And that becomes the coefficient, as you can see. But now we go down here, right? We're multiplying this row term by this column term. This is what we get. And right away, you can see that on this diagonal, we have like terms. You know, it's just something to note, especially when we have to add the terms together. Over here, what do we get? We have minus x cubed times x. We end up with this. Again, nothing fancy. We're just multiplying monomials together. And again, you can see that these 2 terms are like terms. Okay. Finally, we have this. which really, like the one above, becomes this. Now we have all the terms. Now what we can do is get the actual product by adding the grid entries. Doing so, we get this. Okay? Right? Again, we're adding them up. There is some cancellation, right? Because we have like terms. You know, x to the 5 and minus x to the 5, they cancel. Minus x to the 4 and minus 5x to the 4 becomes minus 6x to the 4. And that's it, right? The remaining terms, they're not like terms, so you can't combine them. Like so. Okay, that was fun. That's good. Okay, let's see. Let me just ask, are there any questions about this? Let me just pause the recording, then I'll resume it.